Let us now give an example of convolution. So we are going to talk about convolution of uniform random variables. So x and y are uniform random variables, so their density function is, say, f of x is same as f of y, takes on value 1 if this c right here lies in the interval 0 to 1, and it is 0 outside this interval. So now we use the formula for convolution, which basically goes from minus infinity to plus infinity. But since this function is 0 outside 0, 1, we just drop minus infinity and plus infinity and instead focus on the interval 0 to 1 where the function is non-zero. So we have this density function of x, and then you have this density function of y. Now notice that the density function of x and y is just 1. So this is 1 and this is 1. But the problem is that c goes from 0 to 2, because although these random variables x and y are taking values 0 and 1, but if you add them up, you could have 1 plus 1, which is 2. So we need to worry about 2. So if c lies between 0 and 1, everything is simple. You go from 0 to c and dy, because f of x is 1 and f of y is 1. But if c lies between 1 and 2, there is a problem. So notice that limits of integration are from 0 to 1, because we have the c lying right here 0 to 1 for each of these density functions. So the trick is that c might lie between 0 and 2, but c minus 1. So if c lies between 1 and 2, then c minus 1 lies between 0 and 1, and that solves our problem. So you plug in c minus 1 right here, c minus 1 to 1 dy. So f of x plus y c gives you c, this one right here, if c belongs to 0, 1, and it gives you 2 minus c if c belongs to 1 and 2. So again, the entire trick here in this case was just to play with these limits, because both these density functions are just 1. And notice that when we started, c lies between 0 and 1, but obviously we are talking about x plus y now. So c could go from 0 to